Okay, so let's continue our topic motion. We have discussed till now the velocity time graph. Okay, when the body is in a uniform velocity, when the body is traveling with a uniform velocity, that is uniform motion. And we have seen that when the body travels in uniform motion, its velocity time graph is a straight line parallel to the horizontal axis. Now let's consider the second case in which the body is traveling with uniformly accelerated motion. Okay. Now what is uniformly accelerated motion? When the speed of the body or the velocity of the body increases by equal amount in equal intervals of time, we call that motion as uniformly accelerated motion. So let me first write the definition of uniformly accelerated motion. When a body, when the velocity of a body increases by equal amount in equal intervals of time, then the body is said to travel in uniformly accelerated motion. Okay, then the body is said to travel in the uniformly accelerated motion. So for that, let us consider a case, let's consider a situation in which the body is performing a uniformly accelerated motion. Let's say there is a ball and this ball is traveling, let's say, with 0 meters per second speed at t is equals to 0. It means when I observed the ball for the first time at t is equals to 0, the ball was traveling with the speed of 0 meters per second, that is, the ball is at rest, okay, at 0 meters per second. After some time, let's say after 2 seconds, t is equals to 2, after 2 seconds when I saw the ball, it is traveling with the velocity of, let's say, 10 meters per second. Okay, and after this, after more 2 seconds, that is t is equals to 4 seconds, when I saw the ball is traveling at, let's say, 20 meters per second. Okay, similarly after some, let's say, 6 seconds, after 6 seconds at t is equals to 6, when I saw the ball, it is traveling with speed of 30 meters per second, the velocity of 30 meters per second, and similarly after 8 seconds the ball is traveling with the velocity of, let's say, 40 meters per second, okay, and so on, okay, and the speed goes on increasing with time. So what I can see, if I draw the table of this complete data, I will find that here I will write the time and here I will write the velocity. So 0, 2, 4, 6, 8 and so on. So velocity was 0, 10, 20, 30, 40 and so on. Okay. So this is the data that I have. You can see with increasing time the velocity is also getting increased, and you can see the velocity is increasing by equal amounts. Okay. For example, in first 2 seconds the velocity increased by 10 meters per second. Previously it was traveling with 0 meters per second, now it is traveling with 10 meters per second. Then after more 2 seconds the velocity is increased again by 10 meters per second and becomes 20 meters per second. Similarly 30 and similarly 40, so it means velocity is increasing uniformly at a constant rate. Okay. So if I want to plot the graph for this particular situation, I want to plot the velocity time graph of the situation. So this is the time. Because the time is an independent quantity, we will take it on x-axis, that is horizontal axis, and on y-axis we will plot velocity. In meters per second. So like this we will going to plot the velocity, and here we will plot the time. So let's mark the points. This is, let's say this is the 0, this is 2, this is 4, this is 6, and this is 8, and similarly this is 10, this is 10, and then this is 20, this is 30, this is 40, and this is 50, 50, and then so on, it will go on increasing. Okay. So what I can see, at 0 means the first time when I saw the ball it was at rest, so the point, this point will be the first point. Okay. Then at 2 seconds the speed is 10 meters per second, so you can see this is 2 and this is 10, so if I join it like this, this is the position of the ball. Okay. And after that, at 4 seconds the speed is 20 meters per second, so this is the position, and at 6 seconds the speed is, you can see, 30 meters per second. Then at 8 seconds the speed becomes 40 meters per second, and so on. So this will going to increase. Now if I join these lines, or if I join these points, what I will get is a straight line. Okay. If I join all these points, I will simply get a straight line like this. Okay. So this straight line indicates that the motion of the ball is, or the motion of the body is, uniformly accelerated. So we can say that when velocity time graph of a body is a straight line inclined to x axis, we say the body is in uniformly accelerated motion. Okay. So the body is in uniformly accelerated motion when the graph, velocity time graph, is a straight line. Okay. And it is inclined to the horizontal axis like this. It's inclined to some angle, horizontal axis. Okay. Now what is the significance of this graph? Why this graph is an important tool? It's because using this graph we can calculate two things. The first one is the distance traveled. Okay. Because we know that the velocity time graph, the area covered under the velocity time graph, gives us the distance that we discussed in the previous case, and in this case we can also calculate the acceleration of the body. Okay. That at what rate the velocity is getting increased. Okay. So I will write here, we can calculate two things using this graph. Okay. So first one is acceleration and the second one is distance traveled. Okay. So acceleration and the distance are the two things that we can calculate. Okay. So first you note these things, then I will rub this much part, and using this graph we will understand how to calculate the acceleration and the distance traveled. Okay. First note this. Okay, so using this graph, let us calculate the acceleration of the body and the distance traveled by the body. Okay, so first we will start the discussion of calculation of acceleration. Now, how to calculate the acceleration? So for that, recall the definition of acceleration. What is acceleration? It is the change in velocity per unit of time. That is, how much change is occurred in the velocity per unit of time. In every unit of time, how much change is there in the velocity. Okay. So for that, let us consider 2 points on this graph. Let's say this is the point A and this is the point B. Okay. Now, point A, let us assume that point A represents V1 velocity at t is equals to t1 time. Let us assume that point A represents the velocity V1 which was at time t1. Okay. Similarly, let's assume this point B which represents V2 velocity at time t2. Okay. So V1 represents the velocity at time t1 and V2 represents the velocity at time t2. Okay. Now, to calculate the acceleration, we have to calculate the change in velocity happened per unit of time. So what we are doing, we are considering the time interval from t1 to t2. Okay. We are considering the time interval from t1 to t2, and in this particular time span, you can see velocity varies from v1 to v2. Okay. Simply consider this time interval t1 to t2. In this time interval, you can see where velocity varied from v1 to v2. Velocity changes from v1 to v2. So what I will say here is, we consider time interval from t1 to t2 and velocity in this time interval varies from v1 to v2. Okay. So velocity varies from v1 to v2 in this particular time interval t1 to t2. So it means what we can see, change in velocity is equals to v2 minus v1. Okay. What is v2 minus v1? It is the change in velocity, and in how much time this velocity is changed. So the time interval for change in velocity is equals to, you can see 0 to O2, sorry 0 to this T2 is the T2 time, this T2 seconds, and from 0 to T1 it's the T1 seconds. So if I want to consider the time interval from T1 to T2, so I have to subtract this OT1 from this OT2. Okay. So OT2 is a bigger time interval and OT1 is a smaller time interval. I have to subtract this time interval from this to get only this much time interval. So I will say time interval for change in velocity, that is from v1 to v2, it is t2 minus t1. So t2 minus t1 seconds is the time interval, and v1 minus v2 meters per second is the velocity, is the change in velocity. Now, how the acceleration is calculated? Acceleration is change in velocity upon time. So here I will say acceleration is equals to change in velocity upon time taken, that is time taken for this much change in velocity. So here we will say change in velocity is v2 minus v1 upon time interval is t2 minus t1. This is v2 minus v1 upon t2 minus t1. Now observe this particular expression in the graph. If you see v2 minus v1, so what I can do, if I join this line here, let's say this is C, this is D, this is E. So what is v2 minus v1? v2 minus v1 is this much length, and BC is equals to v2 minus v1. Okay, this BC is v2 minus v1. Similarly, what is T2 minus T1? Observe this T2 minus T1 is equivalent to AC. So I am dividing this BC by this AC. Now recall what we have studied in the distance time graph. We studied a concept known as slope. Okay, slope is what? It is the ratio of this perpendicular upon base. So here also this angle, let's say this is theta, so the theta will going to represent the slope. So we can see that in this case slope is equals to tan theta. And what is tan theta? That is BC upon AC. Okay, it is the same trigonometric ratio. You will study about trigonometric ratios in the mathematics. Okay, so here what is BC upon AC? BC is basically V2 minus V1 upon, and AC is T2 minus T1. So from these two, compare the two conditions. You can see acceleration is also V2 minus V1 upon T2 minus T1, while the slope tan theta is also V2 minus V1 upon T2 minus T1. So from here we can clearly say that the slope of velocity time graph gives the acceleration of the body. Okay, of the body. So the slope, that is tan theta, so we can write in case of velocity time graph, in velocity time graph we can say tan theta, or we will write in this way, acceleration is equals to tan theta. Just recall what we studied in distance time graph. The slope in distance time graph gives you the velocity, but in this case of velocity time graph we have the slope as acceleration. Okay, so this is how we can calculate the acceleration of the body in a uniformly accelerated motion using velocity time graph, using its velocity time graph. Now how to calculate the distance? Next concept is to calculate the distance. Calculate distance traveled. Now how to calculate the distance? We have seen that distance is basically the area under the velocity time graph. So what we are considering? We are considering this much part of the area, this much part of the velocity time graph, that is from A, B, D, E. Sorry, yeah, A, B, D, E is the part which we are considering. So here I will write, distance travelled is equals to what? Now in this case we are considering this A, B, D, E. So this is the particular part or the situation or the time interval which we are considering from T1 to T2. Okay, so here I will say distance travelled from T1 to T2 is equals to, from T1 to T2, that is from time interval T1 to T2, or in the interval T1 to T2 is equals to area of A, B, D, E, area of the curve or the area of the figure A, B, D, E. Now you can see ABDE is formed by two different figures. ABDE is the combination of triangle ABC plus this square or the rectangle ACDE. Okay. So here I will write area of ABDE is equals to area of triangle ABC plus area of rectangle, this is ACDE. Okay, this is a rectangle. Now what is the area of the triangle ABC? Area of triangle ABC is half into base. What is base? Base is AC into height is BC. Plus what is the area of this rectangle? Area of rectangle is length into breadth, that is AC into CD or AC into AE, whatever you want to write. This is CD. Okay. Now what is AC? AC is equal to T2 minus T1. What is BC? BC is equals to V2 minus V1. Okay, this much length. V2 minus V1. Similarly, AC is again T2 minus T1, and what is CD? You can see CD is this length. So this C point lies parallel to this V1. Okay, so CD is basically V1. So the distance travelled will become half into AC is T2 minus T1 into BC. BC is this much, that is V2 minus V1 plus T2 minus T1 into CD is V1. This is V1. So this is the distance travelled. So this is the distance travelled. This is the expression for distance travelled when a body performs uniformly accelerated motion. This distance can be calculated using this graph, okay, the velocity time graph. Okay, so this completes our basic graphs. Now we will move on to the next concept, that is the concept of equations of motion. Okay, first you note this. Okay, now let's consider the third case in velocity time graph, and that is when the body is, third case or case number C, when the body is in non-uniformly accelerated motion. When the body is in non-uniformly accelerated motion, that is when the motion of the body is non-uniform, or we can say the acceleration is non-uniform, that is the speed is varying, speed is either increasing or decreasing, but that increase or decrease is not even constant. That increase or decrease is happening with the rate which is not constant, which is changing with time. Okay, so what we can say, non-uniformly accelerated motion means when a body or when the speed or when the velocity of a body changes by unequal amount in equal interval of time, we say the motion is non-uniformly accelerated motion. Okay, so let's consider a situation for non-uniformly accelerated motion. Let's say this is a ball, okay, which was at 0 meters per second at t is equals to 0. It means when I first saw the ball was at rest at t is equals to 0 meters per second. Okay, at t is equals to 0 seconds. And after, let's say, 2 seconds, when I saw the ball the ball was moving with the speed of, let's say, 5 meters per second. Okay, so after 2 seconds when I saw the ball is moving at a speed of 5 meters per second, and after 4 seconds when I saw the ball, okay, when I saw the ball after 4 seconds, the ball is moving with the speed of, let's say, 15 meters per second. Then after 6 seconds when I saw the ball was moving, at that time the ball was moving with a speed of, let's say, or let's take this as 12 meters per second, and let's take this as 25 meters per second, okay, and so on. And at t is equals to 8 seconds, let us say the ball was moving with the speed of 40 meters per second. So what we can see, the ball is getting accelerated, the speed of the ball, the velocity of the ball is continuously increasing with time. So if we write this data in a tabulation form, in a tabulated form, so this is the time and this is the velocity, what you will find, the time period that we have is 0, 2, 4, 6 and 8, okay, and so on. This will go on increasing, and the velocity is 0, then 5, then 12, then 25 and then 40 and so on, okay. So the velocity is getting increased with time. So if I want to plot this situation on a graph, let us try to plot the situation on a graph. This is velocity, okay, in meters per second, and this is time in seconds. So this is the time interval, this is 0, 2, 4, 6, 8, 10 and so on, okay. Now if I consider the speed, it is, let's say, this is the divisions, like this. Let's say if I consider this as 5, this is 10, this is 15, this is 20, this is 25, this is 30, this is 35 and this is, let's say, 40. So at 0 meters, at t is equals to 0, the ball is at 0. So it means this was the position of the ball. At t is equals to 2, the ball is traveling with the speed of 5. So this dot will represent the position. At t is equals to 4, the ball is moving at 12. So it means just above 10 we have a position like this. Let's say this is the, at t is equals to 4, then at t is equals to 6 it is moving at a speed of 25. So this is 25 and this is 6. So this is the position, and at t is equals to 8 it is moving with the speed of 40. So this is the 40. So this is the position, okay. So these are the positions of the ball which we can see. Now if you try to join these lines or join these points, you will find a curve like this, okay. A curve which is not a straight line, rather it is moving upwards, it is moving like this, okay. So this will show that the ball is moving with a non-uniform acceleration, that is, the acceleration of the ball is getting increased or decreased. We will understand that concept. So you can see the line is not a straight line. So here we will write, for non-uniformly accelerated motion, the graph will not be a straight line, okay. So graph will not be a straight line in case of a non-uniformly accelerated motion. then what will happen? The situation will be, for example, if you consider the point A, somewhere on the graph, let's say this is point A, then let's say this is point B, then let's say this is point C. So what I can do, I can calculate the acceleration at these 3 points. How to calculate the acceleration? We studied that tan theta gives you the acceleration. So for that I have to draw a line which is touching this point like this at point A. Let's say this is the line that I can draw, and let's say it forms an angle theta 1 with the horizontal axis. Similarly, from point B also I can draw a line which touches the horizontal axis, and let's say it forms an angle theta 2 with the horizontal. Similarly, I will draw a line from this point C like this, and I will see that this angle is theta 3. Now the most important point is, as you move forward in time, okay, you can see point A is forming an angle of theta 1, it is forming an angle of theta 1, B is forming an angle of theta 2, and C is forming an angle of theta 3. You can see the 3 angles. The most important point here to note is that in our situation, in this particular case, you can see theta is getting increased. You can see theta 1 and theta 2. So compare the theta 1 and theta 2, you will find theta 1 is smaller while theta 2 is a greater quantity. And compared to theta 2, theta 3 is a bigger value. So what we can say, as we move with time, the theta will going to increase. And the most important point, we studied that slope of this VT graph, velocity time graph, slope that is tan theta gives you the acceleration. So if theta increases, the acceleration will also increase. So you can see, if theta is greater than tan theta, then tan theta 2 and tan theta 3. Okay. Now what does this tan theta 1 will represent? Tan theta 1 represents the acceleration of the body at point A. Okay. Tan theta 2 represent the acceleration of the body at point B, and tan theta 3 represent the acceleration of the body at point C. So if tan theta 1 is the smallest, it means acceleration at point 1 is the smallest, or point A, then acceleration of point B and acceleration at point C. So this is a relation that we can get. So what we can see, the graph is moving like this. So if graph moves like this, we will say this graph shows increasing acceleration. Okay, this graph shows that the velocity is increasing, but the acceleration is also getting increased. Okay, the acceleration itself is increasing. You can see from here to here the velocity changes by 5, from here the velocity changes by 7, then here it is changes by 13, then it is changes directly by 15, and so on. So what exactly is happening? The velocity is increasing, but the acceleration itself is getting increased. So what I can say, that the acceleration of the body is increasing, and that's why the curve is something like this. It is going in upward direction like this. Okay. So we have a very important conclusion from here, is that the straight line represents that acceleration is constant. Okay. A curve like this will represent acceleration is increasing. And what will a decreasing acceleration show? Like this. So this type of curve will show acceleration is decreasing. Okay. So this kind of graph, this kind of velocity time graph will show that acceleration is decreasing. This kind of velocity time graph will show acceleration is increasing, and if it's a straight line, it will simply show you that acceleration is constant. So for example, if I have a graph like this, if I have a graph in which the body B1 has the velocity This is the B1 body. It has the velocity time graph with angle theta 1. The body B2 has the velocity time graph as the slope of velocity time graph as theta 2, and let's say there is a body C2 or B3. It has a slope of tan theta 3. So using these graphs, you can compare that which body has more acceleration compared to other. You can see all the three bodies have a straight line Vt graph, okay, the velocity time graph are straight lines, but B1 has the maximum angle, B2 has the small angle, and B3 has the smallest angle. So it means B1 is more accelerated compared to B2 and B2 is more accelerated compared to B3. So using this I can say acceleration of B1 is more than acceleration of B2, which is more than acceleration of B3. So this is a very important conclusion that we can draw, that is using the slope of the velocity time graph, which gives you the acceleration. Okay. So this is all about the non-uniformly accelerated motion, and this completes our velocity time graph. Okay, so you can note this, then we will continue.